Hail and well met, everyone. Welcome to Geek Thyself, a podcast by a nerd for other nerds that love geeking out over random facts and esoteric trivia. My name is Heather, and I'll be your host as we journey into the wondrous land of information. Hi, everyone. So this week I want to talk about a subject that I think most of us are at least somewhat familiar with. You see it on packaging, you hear about it in the news, and that is GMOs, genetically modified organisms. So historically, the oldest GMOs are actually crops and livestock animals that we humans bred to be what we wanted them to be. A good example of this is corn. It started off as a plant called maize that's much more like a wheat sort of grain plant, as opposed to the ears of corn that you and I know today. But through years, probably generations of breeding and selectively choosing which plants to combine, they were able to cultivate it into the crop we now know and love every summer as corn, because corn is delicious. So things like corn are the earliest known iterations of genetically modified organisms. If you break down the definition of genetically modified organism obviously is something living. So you, me, the plants, the trees, my cats, my dogs, all of those sort of things. All of that is an organism. And then modified obviously means changed. And genetically means that you did something to its genetics. Somehow you changed it genetically. So a genetically modified organism is a living organism that has somehow been modified at the genetic level, changed at the genetic level. And that can be through selective breeding. It can be through, in more modern times, the use of laboratory techniques and gene splicing and things like that. But at the very beginning, way back in human history, when we first started messing with genetically modified organisms, what we were doing is selectively breeding animals. Well, animals and crops. It depended on where they were and what they were doing, but the earliest peoples took, for example, wolves. They took wolves and wild dogs in Africa, and through special breeding and selecting which males would mate with which females, they were able to create the dogs you and I know now. Now, some of these breeds that are existing now obviously came many, many, many thousands of years later. But initially, the dogs that early man was using to hunt with and running around with came from genetically modifying them from wolves. Now, the genetic modification was done through breeding as opposed to something in a laboratory where you splice in genes from one plant to another plant. So it's not exactly the same as what people think of as genetic modification now. But technically, it is a type of genetically modified organism. So my cats that live in the house with me, again, perfect example, they are nothing like the wild cats outside, with the exception possibly of my Bengal, since he's actually got some wildcat, more recent genetics in his bloodstream. But that's a whole different thing. So those are the earliest variations we have. And obviously there's a lot of things that have come from that are helpful. If you look online, you can actually look at images of the current crop versus what it used to look like. Corn is a fantastic example because if you look at the original wild plants and roots and maize that corn came from, it looks incredibly different than the corn you and I know today. It looks almost more like a grain or a wheat sort of plant, which is nothing like the big ears of corn you and I eat every day. Well, not every day, but you know what I mean. Dogs and cats are actually another really good example of genetically modified organisms that were done through selective breeding, especially when you look at the huge variety of breeds that we have for dogs and cats. For example, I have a husky and a hound mix. Neither of them look all that much like a pug or a Boston Terrier, but they are technically the same species, even though they're different breeds. So they could theoretically breed with each other. Wouldn't recommend it really, but That's a perfect example of how we've genetically modified these different dogs to look so incredibly different from each other. No one went in and genetically spliced them that I know of. No one went in and inserted DNA from a different creature into these dogs to make them look this way. We just bred them to look this way, but we still genetically changed them to not be what they used to be. So, earliest GMOs are things like that. And as I said earlier, a lot of the crops that we have now, in one way, shape, or form, fit this bill. Now, some of the more recent types of fruit combinations and things like that have come out, I'd have to look into them more. I'm not 100% if any of them involved genetic actual manipulation in a lab. Some of them may have just been combinations of grafting, which is where you can take a branch from one type of tree and attach it to another fruit tree. One of my great-grandparents did a lot of that on his farm way back when, that sort of thing. But there's also the possibility that someone did go in and genetically combine the two fruits, although not entirely sure why anyone would bother doing that. But who knows, maybe somebody really wanted a pluot, the plum apricot thing that they have out there now. Either way, earliest examples are just from choosing who's going to breed with who. And to a certain extent, not nearly the same extent, but to a certain extent, humans have done it to themselves. But it was more of a choose the fittest mate situation, as opposed to necessarily actively trying to get ourselves to a specific spot genetically. It's not, the same as someone who's going to choose between multiple pugs to breed together because they want a very specific set of standard look to the pug. That's, as far as I know, hopefully not what humans did, but eugenics were a thing at one point where people were looking into it. And that was another way that they were looking at doing some genetic modification without having to necessarily do it in a lab. But that would be where all of those eugenics type conversations come into play, and that's not what this particular episode is supposed to be about. So continuing with discussions of early genetically modified organisms, we know from my previous episode where I talked about genetics specifically that there are different alleles that exist, and these different alleles have different traits. Well, essentially what early man was doing when they genetically modified dogs and cats and corn and whatever else is that they were selecting for the alleles that had the phenotype they wanted. So the allele was the gene variant, and then the phenotype is how it expresses. So they were selecting for, again, let's use a dog example because it's easy, for pugs. People were selecting for small size. So what that meant is that they would continue to choose the dogs that expressed with the phenotype small as opposed to phenotype big. So the phenotype small dogs were then continually bred, and over time, the existence of other alleles for size, the size gene, would be significantly lower or gone, and changed over time, over and over and over again. So eventually, you end up with a breed of dogs, the pug, that is a small-sized dog. Now, to be clear, I don't think there actually is a single gene that dictates how large or small a dog is. I have no idea. Didn't look that up. But this was just a very rough, in theory, sort of example for you. So we know that humans were selecting for specific expressions, whether it's large, small, tasty, sweet, fluffy, whatever. And those different alleles then become the dominant one in the grouping. And eventually, over time, we basically did evolution on these creatures ourselves. Except we were choosing what was going to happen as opposed to the creatures naturally evolving into something else on their own. In this way, we sort of genetically modified them, or, depending on the terminology you want to use, we genetically engineered them to be what we wanted them to be. We didn't use science-y technology stuff because it didn't always exist at the time, way back when, but we still figured out a way to do it. In more modern times, the genetically modified organisms tend to be genetically modified in a lab. There are still, obviously, some examples of selective breeding or of people trying to do crossbreeding and cross-pollination. The fruit tree situation that I mentioned earlier is a perfect example, because the fruit tree with the graft on it will continue to grow, as does the graft if everything goes correctly. What then happens is when that particular tree flowers and blooms, the new branch that's been added to the tree also can cross-pollinate with the other flowers that are on the tree. So, for example, an orange tree can have the cross-pollination happen after the grafting. And so, in that way, early farmers could alter trees. It's likely one of the ways that early apples were also created, because originally, I don't know if anyone's ever tasted a crab apple. They're pretty nasty. I don't recommend anyone eating it. Just don't. But that is one of the sources of some of the earliest apple species. They started as the wild crab apples, but then over time, farmers were able to select for the trees that were sweeter and ultimately bred them to be the apples we know now. The other original version of an apple, so the wild apple plant, which actually is more similar to current apples than crab apples, surprisingly, is called the Malus sieversii. Not 100% sure I'm saying that right. It's Malus, and then second word is Sieversii. It originates in the mountains of Central Asia, particularly in areas like Kazakhstan. It's the oldest known progenitor of apples, and then over time, crab apples got mixed into. But that just makes my point. Again, we changed apples from being that wild Kazakhstan-based apple to something completely different, and we've even got different variations on it again. So obviously, things like apples and corn and the cats and dogs that we know and love are examples of ways that early genetic modification through breeding worked out pretty well. There are some examples of times when it hasn't, or times when it's perhaps gone too far. One of the best examples that I can think of is killer bees, the Africanized bees situation. So African bees, African honeybees specifically, create more honey than the European ones that you and I here in the US are more familiar with. Unfortunately, when people started crossbreeding some of those African bees with our European honeybees that we were used to, they weren't prepared for how aggressive it would make the honeybees. So that whole Africanized bee scare was started because someone was attempting to mix the two and genetically modify them to produce more honey while still having the temperament of the bees you and I are familiar with. We all know from, old news stories and whatnot that didn't work out quite as well as they had hoped, unfortunately. So now there are some areas that have to deal with Africanized bees that have become more aggressive than their original honeybees that they had. The second example that I think is a really good one of how we have genetically modified an organism in a negative way is actually the British Bulldog. I want to be clear, I think British Bulldogs are adorable, and I know they are a very nice, sweet breed of dog, and that a lot of people love them, and I don't think they are a bad dog in and of itself. Like, if you want a British Bulldog, go get a British Bulldog, whatever. The problem is that we have bred them to have such large heads that the vast majority of British Bulldogs can no longer give birth naturally. They're almost all exclusively born via C-section because we, humans, chose to make their heads so large that the female dogs can't pass a baby's head through her hips to give birth to it naturally. It's not physically possible for most of them. And I think that's obviously, for obvious reasons, not the best. Again, nothing against the breed in general, but just something that I think we did to them that makes me very sad. Another animal example that I actually just remembered for the same reason is unfortunate. The turkeys that you and I have Thanksgiving, Christmas, whatever, unless you're vegetarian, in which case this doesn't apply to you. But we have bred turkeys that are held in captivity for meat to have such large breast meat that the male turkeys actually can't mount the females anymore. They can't breed naturally anymore. They all have to be artificially inseminated because the breast meat on the male turkeys is so big they can't physically get onto the females and stay up to mate with them. It's too much meat between them and the female to actually get the deed done. So all of them are artificial insemination for the most part. Now, if someone had some wild turkeys mixed in with them, maybe that would be a different story. But if you look at a wild turkey, especially like I live in California, and in the area I live in, we've had flocks of turkeys flying around. We've had them land on our roof. They look very different than the turkeys you see at farms here in the U.S. and probably in other areas as well. They're much leaner and more streamlined, which makes sense because they fly. And they also have much smaller chests. They don't have the huge rounded white chest like what you see on cartoons and things of turkeys. They have a much leaner look to them. So that's another example of how we genetically modified something in a negative way. We did it through breeding, not through splicing things together, but it's still something we did, and it's still technically a genetically modified organism because we genetically changed them to be that. So we're going to take our break, and when I come back, I'm going to talk to you more about more modern versions of genetically modified organisms, as well as how they do it now, as opposed to how we did it way back when with the breeding that I've talked about. Okay, everyone, so thank you again for joining me here in the middle of the episode to talk about some of the other great shows at Nerdsmith. For anyone who actually listens to it and doesn't skip it, thank you very much. I appreciate it. This week, I want to talk about just one of our other shows, and that is Shenanigans. It's the actual play podcast here on the network that I'm in, and we're set in a 5e D&D homebrew world called Vale. You get to follow my character, Val the Cleric, as well as Merrick the Rogue, played by Kyle, Adelaide the Arcane Archer, played by Angela, Bonnie the Half-Elf Bard, played by Tessa, and Arthur the Human Warlock, played by Mike, who's actually my husband. You get to hear all the crazy antics that our characters get up to, including things like impersonating dire ferrets and drinking some smush wine with a little goblin named Pugnut. Lots of fun stuff. Definitely recommend you check it out. It's at nerdsmith.org, of course, and you can also find it on iTunes or wherever you download your podcasts. And that actually leads me into my second subject for this little mid-episode break, where I just want to shout out again to everyone who's a regular listener, and also ask, please, please, please don't forget to go give us reviews online if you do listen to any of the Nerdsmith shows. It's really those reviews that help fuel other listeners, as well as get our names out there so that people hear about these shows, which you're listening to, so you obviously enjoy, or at least I hope you enjoy. So please go ahead and give us a review, 5 stars, 4 stars, whatever you feel is appropriate. But reviews, word of mouth, all of those kinds of things, we really appreciate it. You can also find us on Twitter. We have one for Nerdsmith itself, which is at WeAreNerdsmith. My personal Twitter is at amethyst_magic, and that's magic with a CK at the end. There's also one for Geek Thyself, which is at geek_thyself. Either of those you can tweet at me and I'll get it. And if you have any specific topics you'd like me to cover in these episodes, please let me know by posting it there and tagging me in it. And with that, let's get back to this week's episode. Okay, so now on to more modern genetically modified organisms. The one that you and I would be most familiar with and that we see on a very regular basis are actually food crops. So I mentioned corn earlier. The obvious first genetic modification that I mentioned was just selective breeding. But then in more modern times, corn and other species of plants and crops that we eat on the daily basis have been genetically modified for various reasons. Some of the most common reasons include things like making them more drought tolerant or making them more pest resistant, things like this. Some of these genetically modified crops have been improved so that they don't spoil as quickly, or so that they can be grown in areas with more water or less water, or that are colder. Things like that can help make them viable for people who don't live in the ideal environment, thereby making it possible for people to grow it and eat it. So especially in areas that are harder to grow things in, more arid, dry areas such as parts of Africa, for example, creating plants that are crops that can be resistant to those drought periods they have periodically throughout the year make it so that it's easier for them to grow the plants still, and therefore easier for them to have food to eat. So there are a lot of good benefits to some of these genetic modifications that get put into the plants. Now, a lot of people worry about what the effect is going to be on humans. And admittedly, we don't necessarily have tons of research done on that yet, because genetically modified organisms have only been around since the 70s. The very first truly genetically modified organism, not just special breeding, but actually genetically we altered it, wasn't created until 1973. It was developed by Herbert Boyer and Stanley Cohen, and they took a gene from a type of bacterium that was resistant to a specific antibiotic, and they inserted it into a plasmid, and then they took that plasmid and got another bacteria to take it up. So basically a piece of DNA, and they got the other bacteria to suck it up and combine with it. And then that second bacteria was able to survive in the presence of the antibiotic that was a problem for it. So by doing this, they were able to get genes from one bacteria into another. And then a year later, in 1974, Rudolf Janisch, I'm not entirely sure I'm saying that last name right, Jaenisch, Janisch, something like that, created the first transgenic animal. He took a mouse and introduced foreign DNA into its embryo, which made it the first transgenic animal. And it was several years before the offspring continued to have the gene he had put into it, but he was the first one to create a genetically modified animal, specifically, beyond just the breeding like I mentioned earlier. So really, these items have only been around since the 70s. It's only been 30 years. It's been more than one generation, but initially when they were first developed, they weren't widely used yet. It wasn't until many years later that the FDA actually approved some of these genetically engineered plants and other things being used that they started getting into the food supply. So, for example, the first transgenic or genetically modified livestock weren't introduced or weren't even produced until 1985. And genetically engineered plants weren't created until 1983. So even though it's been 30 plus years, it still isn't so long that we've necessarily seen fully what the effect would be long-term on humans. Thus far, as far as most people know, there haven't really been that many issues with it because they're being very careful. They're not just going in and saying, ooh, I want to make things green, or ooh, I want to make things pink. For the vast majority of it, the ones that are getting changed that then get put into the consumption for you and me are ones where it's very simple things, like what I was talking about, wanting to make a plant more drought resistant. So they splice in a little piece of another plant. But it's not like they're going to take a tomato and splice in part of a poison sumac plant that's going to make everybody itchy when they touch the tomato. It's not those kinds of things that they're doing. They're going in and taking a tomato plant and splicing it with, genes from a plant that doesn't need as much sun, or perhaps some plant that doesn't have as much of a problem with cold temperatures, things like that then make it so the tomato can grow somewhere else. So yes, they are going in and inserting new DNA, but not necessarily to the negative effect that some people worry about. A lot of genetically modified organisms have also been used to develop medications. A really perfect example is humulin insulin, which is used by a lot of people out there. It was developed by a company called Genentech, which was actually a company founded by Herbert Boyer, one of the guys who created the first genetically modified organism with the bacteria, and a man named Stanley Cohen. They created the company, and they were able to have the humulin insulin, which is actually produced by bacteria. Genentech was able to create an E. coli bacteria that could produce the somatostatin human protein, and humulin insulin is a protein-based hormone. So they were able to create the humulin. And that's just one of many medical situations where genetically modified organisms, often involving things like bacteria or viruses or what have you, they've been able to use them to create medications and create things that then help keep us healthier and live longer. So again, back to some people really worry about trusting GMOs. You have to keep in mind that some GMOs are things we just bred to be different, and some GMOs really do have genetic manipulation done to them in a lab somewhere, but it's not necessarily going to be a bad thing. It might make the crop stronger. They might boost a particular vitamin in the crop. They might do something else to it that'll make it so that it can survive in another area, and then people that need food there can grow the crop and have it actually survive. Things like that. It is true, though, that not all of the genetic modifications that get made are really necessary. For example, the first genetically modified animal that was able to be sold commercially in the US is called the Glofish. I have to admit, my husband and I actually have some of these, but what they did is they took a zebrafish, ours happened to be tetras, and they inserted a fluorescent gene. So if you turn on a black light, the fish glow under UV light, under the black lights, which is really cool looking. Was it necessary? No. Did it hurt the fish? No. There's some of our longest lived fish in that tank. But nonetheless, it was a thing that didn't necessarily need to be done. Another example is the first genetically modified animal that was actually approved for food use. It's called the AquaAdvantage Salmon, and it was approved by the FDA in 2015. And what they did is they put a growth hormone regulating gene from a Pacific Chinook salmon and a promoter from an ocean pout together, which then enabled the salmon to grow year-round instead of only during spring and summer. So it'll grow during winter and fall as well, thus creating a much larger salmon. This isn't something that's going to be released out into the wild. It's definitely not wild-caught salmon. This is the fish farm salmon. But they did that in order to produce bigger meals, bigger meat. Was it necessary? I mean, depending on who you ask in the industry, maybe. Personally, I could go either way. I mean, on the one hand, if they're making it bigger and it's growing faster, they may not have to catch as many in the wild, which means, animal lover that I am, I want nature to continue existing. So that's always a good thing. But the glowfish in particular, was it necessary? No. Does it look really cool under a black light? Absolutely. Can confirm 100%. But not necessarily a needed genetic modification. So those are some examples of more modern ones that you can see on the daily. I do know that a lot of pet stores now I've seen carrying the glowfish, so if it's something you're interested in seeing firsthand, even if you don't want to buy them, even if you don't want to have fish, if you just kind of want to see what I'm talking about, and see an example of genetic modification that didn't necessarily cause any major harm to the animal and really didn't cause any harm to us, that's a good example, and it might be fun for the kids if you happen to have those. In terms of sources, this is another one where a lot of the information was things I already knew, simply because my major at UC Davis when I went to college was agricultural and animal-based, animal science specifically. So I learned about some of these things just in my classes. Couldn't tell you specifically which class or specifically what day or anything like that for sources, but I can tell you that I learned it in college. Some of the finer details, things like when did Genentech develop X, Y, and Z, and when did X, Y, and Z happen, I did look up dates on Wikipedia, but then confirmed them on other websites as well, such as the websites for the actual Genentech company and things like that. So I did double check myself, but the original source was Wikipedia, not gonna lie. Honestly, in most cases, Wikipedia is not a bad source, as long as you make sure that if anything sounds strange, you vet it, and you should not make it your only source. Definitely want to say that. I have used it to look at other dates and then double-checked them elsewhere, but I would not consider it a primary source for most things. Too much chance of someone editing it and having it be not technically the correct information. Please remember to check out the other wonderful podcasts and productions here at nerdsmith.org. I'll be back next week with a new and interesting topic, and until then, don't forget to geek thyself.
Dust off your dice and hold on to your butts. Do you love magic, mystery, intrigue, and romance? Of course you do. Meet
Rowan, the enigmatic bard.
Atlas, the blacksmith, what a heart of gold.
Kristoff, the sorcerer who enchants with both fact and fiction.
Join our heroes as they unmake the best laid plans of their indomitable DM in
The
Lawful
Stupid.
Crosswords with Will Crossway. Advice and analysis for the musician at the gaming table. Available on nerdsmith.org or wherever you watch your YouTube videos. YouTube, right? Probably YouTube.